In the last section, we learned about some interesting things that happen when you have two parallel lines crossed by a transversal. And in this video, we're going to learn another way that we can use that information to, as you can see, prove that two lines are parallel. And so let's jump right in and take a look at how we're going to use the information from the last video to prove lines are parallel. So you can see on your note sheet that you're going to have a table that lists 6 different ways to prove that two lines are parallel, and the first 4 of those all start with converse of. Converse of the corresponding angles theorem, converse of the alternate interior angles theorem, converse of the same side interior angles postulate, and converse of the alternate exterior angles theorem. Just as a reminder, if our original statement says if P then Q, then the converse of that statement says if Q then P. So the corresponding angles theorem itself said if two parallel lines are crossed by a transversal, then the corresponding angles are congruent. The converse says if a transversal intersects two lines and the corresponding angles are congruent, then the lines are parallel. So what this would look like in a picture is we might see a line that we call M and another line that we might call N, and then we have a transversal going across it that we'll call T. And then we see in that picture that maybe this angle right here and this angle right here are congruent. We'll call that angle 1 and angle 2. Those two angles are corresponding angles. They're both to the left of the transversal and then above one of the other two lines. Angle 1 is left of the transversal and above line M. Angle 2 is left of the transversal above line N. So when we see that, we would be able to say, hey, if angle 1 is congruent to angle 2, then line M is parallel to line N. The next one is the converse of the alternate interior angles theorem. So what this is going to say is if a transversal intersects two lines and the alternate interior angles are congruent, I did a little abbreviating on that one, then the lines are parallel. Then the lines are parallel. So again, what this might look like in a picture, maybe we have line M here, we have line N here, we have a transversal going across there, and perhaps we have angle 1 here and angle 2 here, and those two angles are congruent. Those two angles are alternate interior angles. They're both interior angles because they're between lines M and N. They're in that space between those two lines. Angle 1 is above the transversal and angle 2 is below it. So they're alternate interior angles. In that picture, if angle 1 is congruent to angle 2, then line M would have to be parallel to line N. Next up, we have the converse of the same side interior angles postulate. Same side interior angles postulate said that if two parallel lines are intersected by a transversal, then the same side interior angles are supplementary. So the converse says if a transversal intersects two lines and the same side interior angles are supplementary, then the lines are parallel. So in a picture, what we would see perhaps is we would have, again, line M that's like that. We might have line N that looks about like that. We have our transversal cutting across both of them. And then we have angle 1 and angle 2 there. But now instead of them being congruent, if I add them together and it equals 180, then line M is parallel to line N. Finally, we have the converse, the alternate exterior angles theorem. So the alternate exterior angles, we know that when the lines are parallel crossed by a transversal, the alternate exterior angles will always be congruent. So the converse says if a transversal intersects two lines and the alternate exterior angles are congruent, then the lines are parallel. And the lines are parallel. So again, picture would look something like this. We have line M, we have line N, we have a transversal going across, and now we have maybe angle 1 up here and angle 2 there. They're alternate exterior because they're both outside the space that's between the lines, so they're in the exterior space. Angle 1 is to the left of the transversal, angle 2 is to the right, and now if those are congruent, that's congruent to that. So if angle 1 is congruent to angle 2, then then line M is parallel to line N. So those four ways of proving lines parallel are all just converses of the things that we learned in the previous section, in section 2-1. Now the next two that I'm going to show you, are a little bit different. So let's take a look at those. These are just called theorem in our textbook. They're called theorem 2-8 and 2-9. And let's take a look at what they say. Theorem 2-8 says if two lines are both parallel to the same line, then they are parallel to each other. They are parallel to each other. So in a picture that would look something like this. Okay, let's say we have line A and we have line B. And line A is parallel to line B, so we're going to show that with those two arrowheads there. Now I'm going to add in line C. And I'm going to say that line C and line B are parallel. So I put those two blue arrowheads there. If that's the case, what that means is that A and C are both parallel to the same line. They're both parallel to B. So we would be able to say, according to this theorem, if A is parallel to B and B is parallel to C, then A has to be parallel to C, because A and C are both parallel to line B. And that's called theorem 2-8, or sometimes I don't make you, or I don't depend on you guys knowing the numbers of these theorems. I'm more interested in you knowing what they say. So this one just says that if two lines are both parallel to the same line, they have to be parallel to each other. Now the next one says if two lines are both perpendicular to the same line. So remember, perpendicular means that they intersect to form a 90-degree angle. So before I finish that, let's just sketch out what that's saying. We have, maybe we have line A here, and it is perpendicular to line C. So it forms a 90-degree angle right there. And then we have another line, call it line B, that is also perpendicular to line C, forms a 90-degree angle. So that's the situation that we're describing. Two lines are both perpendicular to the same line. Then they are parallel to each other. So in this picture over here, if A is perpendicular to C, that symbol that I just used right here, that's the perpendicular symbol. It looks kind of like an upside down capital T. It stands for perpendicular. If A is perpendicular to C and B is perpendicular to C, then A would be parallel to B. A and B are both perpendicular to C, so they're parallel to each other. So that kind of finishes off the 6 different ways that we can prove lines are parallel. 4 of them are just the converses of the theorem and postulates that we learned in the section 1, and then these two new ones are added, and they're kind of related to each other. They're saying, look, two lines have something in common, and here they're both parallel to the same line. Here they're both perpendicular to the same line, so they have that idea in common, and that makes them parallel to each other.